That's not fireballs. That's something else. That's like.
That's me. All right, we're live. Let's get back to where we were. I can't remember which one it was. This one. There we are. Sorry about Oh well, got a cable in the way. That's the way it goes. All right, so we're back. Sorry it took so long. So there's our subtraction that goes with addition. Here's division. We good? So division, they like to. Just because I start talking doesn't mean you get to talk. If you're going to talk, 2 doors. Good?
Yes, sir.
All right. Can't play today. So they factored this guy into 2 binomials so they could cancel. There we go. Final answer is x minus 3. We'll talk about domains and ranges momentarily. I want to do the multiplication piece, right? So if I wanted to multiply, if I said f times g of x, and remember, this, what we're going to see later, is going to have a hole in it. This is not composition of x. And then we're just going to write it out. X squared minus x minus 6 times x plus 2. All right? So I have to distribute this x to every single piece here, and I have to distribute the 2 to every single piece here, right? It's just like foiling, only I have a trinomial here, okay? So x times x squared is x cubed. X times negative x is negative x squared. X times negative 6 is negative 6x. Now I'm going to do the same thing with the 2. 2 times x squared is 2x squared. 2 times negative x is negative 2x. And last but not least, 2 times negative 6 is negative 12. Great. All right. So now we're just going to combine our like terms. We have x terms, and we have x squared terms, right? And we're going to put them together. So x cubed, only one of those. Negative x, positive 2x, gives me positive x squared. Negative 6x, negative 2x, negative 8x. And lastly, minus 12. Good? Shouldn't be any trouble with that, right? The next piece is what they're talking about. What are the domains and ranges of what we get out, right? What is the domain of this quadratic? What's the domain of this quadratic?
Negative 2.
It's infinite, right? This has a different range. I haven't graphed it, so I can't really tell where it shows up. It's below the line. I don't know where it bottoms out because I'm not doing the math in my head right now. But you can graph it on a calculator and then find out where it starts, where it bottoms out, where that min is, and then everything above it would be its range. Here, because it's a cubic function, we know it points infinitely in both directions, right? So our domain and our range will be infinite. Good?
No.
Any questions?
No, sir. Oh, yes, I actually do have a question.
What is your question?
So all we're doing is multiplying.
Well, all we're doing is what they're asking us to do, right? Add or subtract or multiply or divide for this on this front page.
So for that one, we multiply.
Wait.
Here is multiplication, right? Here is division, addition, and subtraction. What may I do for you, sir?
I just connected my College Board and Ambiance account. And Mr. Barkley asked me to send people, like teachers, request for.
And I'll get an email saying it.
I think.
All right, I'm going to move on. Again, I apologize for the cable that's in the way. Oh, they did the others. Oh my gosh. Such a dork, such a dork. All right. Sokol's a nerd. You did it without even worrying about it. Okay. Here, let's do an exercise. Wow. That's mean. We'll do this first one. All right, so let's go ahead and add them first. Right? I have two functions. I have this function and I have this function. And I'm going to add the two together. So f plus g of x is equal to x squared minus 1 plus 2 divided by x. Well, you're supposed to. You're going to do all of it.
Oh, okay.
You're going to do all 4. But is it okay if I just do like addition and subtraction on this and then we'll multiply and divide the other one? I mean, we could spend all day doing all 4 operations. It's kind of annoying, right? Because this is the simple part. Wait, it gets better.
Does it have to?
Right? This is basically done, right? Can I rewrite this?
Yeah, yes.
Can I now?
Oh, wait.
Yeah.
You can write
I'm
it-
just going to go ahead and put my x term in the middle.
I mean, you can
Plus
write
2
it.
over x.
Can you write it as 2x?
Yeah.
You can write it as
Yeah.
2 to the 1 over x.
Yeah, but that's kind of 2 times 1 over x is kind of dumb, right? It's a waste. Sorry, not dumb. Forgive me.
Oh, easy.
There we go. We're done, right? We're finished because those are x terms.
So you can't really simplify it.
Well, there's no more simplification, right? We can't combine any more terms.
Yeah.
All the terms are combined. Maybe we'll multiply. You want to multiply? You multiplied, right? You did? Great. Let's multiply. What the heck?
It's whatever they tell us to do.
It's they want you to perform all different operations. Well, let's go ahead and multiply.
Oh, wait.
And this is nice and easy. It's x squared minus 1, and then we're going to multiply by 2 over x. Right? Cool? Cool. What's x squared multiplied by 2 over x? Well, that's just 2 x squared over x. Right? Can this be simplified? Right?
Yes.
Right, so whoop, whoop. So now I have 2x, and then it's just, what is 1 times anything? It's just itself, right? So it's just 2 over x. So there we go.
The negative 2 over x.
Yeah, it's minus. I left the subtraction symbol in there. Good?
I messed up somewhere.
Well, mistakes happen, man. You're human. Where'd you mess up?
I think I distributed wrong. I ended up with 2x squared minus 2 over x. As in the whole thing over x.
Well, why is that wrong?
It's not, oh, it's just written down.
Well, look at it. All right. Because you're distributing this thing to both, right? So You said 2x squared minus 2, right? Over x.
Yeah.
Yeah? Right? Well, that is the same as this. This middle step here is exactly the same.
Okay, thank you.
That's all. I just simplified it one more step.
Mr. Sampson?
Yeah.
Can you do the F minus G?
Sure. I'll do. So what did we say? F minus G of x, and I'll write it out below. X squared minus 1 minus 2 over x. Right? We're done. We just have to switch order, right? We want our x term in the middle. So we would rewrite it as x squared minus 2 over x minus 1. Done. Just like the addition. Division would be more annoying, right?
Why does the X term go before the 1?
We put it in order of descending order of exponents. Ooh! I wouldn't, would I? Because what's this exponent? Well, it's a 1 here. But if I put it on top, I could rewrite this as 2x to the negative 1. Oh, so cool. Dummy. I want to see it that way. It's a positive 1 right now, so I'll leave it there. Cool. Division. Want to see division? Gross. Right? So, you mind if I erase? Ready? F over G of x. And that's x squared minus 1 divided by 2 over x. Good? How do you divide with fractions? You flip it. Flip what? Okay, and then do what? Multiply by the reciprocal. That's how you say it in math language. Cool? So then say it's x squared minus 1 times 2 over x. Sorry, x over 2. I still want to write it that way. X over 2. There we go. So now we have x cubed over 2 minus x over 2. Yay! Good? All right. Can you guys do me a favor? Add and subtract these. Give me a second. I'll give you a second then. Add and subtract number 2 for me. Add and subtract number 2 for me. You have 2 minutes. It doesn't take long. What are you writing on?
The sheet.
What sheet? Oh, is that where it is? I can't see it. It looks different. Oh, probably because the header is cut off. I couldn't tell what you were writing. Gonna die? Don't die.
I use subtract square root.
You have to subtract the square root.
Leave it.
Okay. So keep going.
Looking at this right now, what's going to be the most annoying one?
Root X.
And what about the root x?
Subtracted effect.
What operation is going to be most difficult with root x?
Multiplication.
Multiplication is not that difficult. You just sit it right next to your whatever term it is.
Subtraction.
Nope.
Addition.
Nope.
Dividing.
Ah, there we go.
Wow.
Why? 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 What can I not have in a fraction?
Negative denominator.
Irrational denominator.
Irrational
We need to rationalize our denominators.
It's fine.
Do you remember how to do that?
If you showed me, I think I'd remember.
Yeah.
Pretend to.
It's just you have to multiply by a factor of 1, which would just be that root x over root x, which would turn this one into x, right? And then there'd be a root x all the way across here, just like when we're multiplying. That's old. That's old school.
Yeah.
Good? Should be done.
No, sir.
Oh, stop it.
I've got one of
My teammates.
There's addition. This is f plus g of x.
Wait, sir, why does the -7 go after?
Because this has an exponent.
It's
So all the exponents go
standard
before?
for anything with an exponent goes before
Yeah.
anything without an exponent.
Oh,
I kind of forgot about that brain.
Square root of x, what's its exponent?
1 over x.
1 over
X squared.
1 half, 1 half, 1 half. This guy right here. So root 3 could also be written as 3 to the 1/2 power. To the 1/2 power, right? Same thing. So there's no reason for you to take more than 1 minute to write that down.
I already wrote it, so it'd be less than.
Sir, my teammate is useless.
It's just like
My teammate is useless.
reverse.
And wow. That position. He's not even finishing it. He's just giving us the equation. So
There you go.
that's
Multiplication was easy. And division was multiplication
How can you close
divided by s. What?
How can you close the minus square root?
Are they not real numbers? This is not a real number. I mean, x can't be negative here, right?
Well, yeah, but x is not a real number.
Right. So we would say where x is not a negative number. Or, you know, if we were talking about complex numbers, we can do it that way.
He's right.
I thought we can.
He's right.
Any questions on these last two answers here?
No, the first two though, so we can't go any further with that equation.
Well, we're done.
No,
We don't
you
have
said
any
that.
values to input for x. We're just trying to
I just like.
operate with functions.
A little bit difficult. but,
Use to operate on functions.
If your name's not-
Domain. These are tough domains. So we're gonna stay positive. Can't really have negative x's because of our square roots. Yeah. Not yet. Not yet. Although it might be. I don't know. I'll tell you what. Let's go ahead and take that. You may go to the restroom.
Take a break.
Take a break.
Stop punching.
We're gonna break early.
Stop talking, everyone. Okay. This is so.
I think I'm gonna change that one to not desk because there's two desks on it.
Like, go get some.
Say it again. Would you ask?
No, sorry.
Explaining to your bad too.
I need to know about.
So 80,500.
I ain't got it.
I'm gonna take a power nap. Sir, is it easy to find the wife? I'm scared. I'm scared of the night. Is it easy to find the wife?
A wife?
Yeah.
Yeah.
It is?
Don't get married.
Why? Aren't you married?
Worst mistake I ever made. No, yeah, it's. You'll be surprised at. That's so funny. You'll just know.
I said I'm sorry.
I may have to break the two of you up again.
I'll go.
Please separate
We're on a break, what are you talking about?
Please separate that.
Yeah, but you were still talking while I was talking,
Exactly.
incessantly.
No talking while
Or just like don't speak while in this room.
We have to have a picture of this.
Our partners can't compensate.
We have to have a picture of this.
That was the easy part. This is the difficult part.
I never said.
Such a monkey.
I thought I was going to get through 2 lessons today. I guess not.
That's a lot of lessons. So.
Yeah, but this stuff is easy. Super simple.
I never said you were communist.
What do you mean you never said he was communist? You said that like 6 times.
No, I'm saying like in the past, but now I know he's the true communist. Yeah,
Oh my God! Stop. What's wrong with being communist?
There's nothing about it. I'm allowed to voice my opinion.
You're saying it like it's a bad thing. We're all here. Okay, let's go. Close them up. Let's go. Let's get back.
I swear it was
Well, we don't need a 5, so we're back. All right, now we're going to do something called composition of functions. Composition is the result of one function being used to evaluate the second. All it means is you input for x the other function, and it's going to be written funny, composition, right? Given the functions f and g, the composite function f of g, or fog, as some kids like to call it, is simple. All you do is everywhere you see an x in the f function, you put that whole function of g.
Well, that's easy.
Super, super easy.
So you just like put it
You
in.
do not want to have to do it by hand.
Here you go, here you go, here you go, here you go. They give you these 2 functions. Here's f of x. Here's g of x. F composed of G, we put G of X in for F. So everywhere you see an X, you put in 4X plus 2. And then there's an X there, 4X plus 2. Then you do the math, right? So you do your distribution. Well, we square it, right? Then we distribute our 3. Then we distribute our 2. We have it all listed out. We combine our like terms, 48 squared plus 56x plus 15. Okay?
Well, it's really easy.
It is. It is. I'm going to move up. And we'll see it the other way around. Right? So G is going to be composed of F, which means we put F of X, G of F of X, and then G, and everywhere we see an X, we put in 3x squared plus 2x minus 1. So here we go. Put in the 3x squared plus 2x minus 1, distribute our 4, and we're done. Right? We didn't have to do any combining of like terms on the second. Cool? Cool? Told you this was easy. Just looks fun.
Yeah,
So this is all just like,
Looks like show.
this is just applying algebra to graphs.
To functions. To functions.
Yeah.
Yes, absolutely. We're seeing what happens if these two functions were combined. Right? We're going to do both. And then we'll use our composition F composed of G, and then put a 4 in when we're done. Okay? Right? That's what that last thing says. So let's go ahead and do F of G of X. And here's G. So in this function, 2x squared minus 2x minus 4 plus 1. Look at how easy that is. Right? And that's why we can just go ahead and say it's 2x squared minus 4x minus 7. Okay, I did my combining like terms at the end, right? It would be minus 8 plus 1, so I just said minus 7, if that's okay with you. You guys are all super smart, you would get there anyway.
Well, that's very easy.
Are you super smart?
Like, do you know before?
I wouldn't say that.
I think you're super smart.
So who do you think here's the dumbest?
I'm not at liberty to say. I don't think there's anybody that's dumb.
I know you do still.
So I think I'm dumb.
You do?
Yeah.
Is it okay if I disagree with you?
No.
It's not okay if I disagree with you.
Yeah.
All right, I'm going to put 2x plus 1 everywhere I see an x here. So it's going to be 2x plus 1 squared, talking again, and 2 times 2x plus 1, and then minus 4, right? Sound good? Sound good? Square it.
Foiling.
4x2 4x
Plus 2x plus 1.
Right? Our 4x's go away, right? Opposites.
Minus
So I have 4x squared
minus 5.
minus 5.
You didn't believe me, sir? No talking.
You have a notebook, right?
Right smaller.
It's pretty crazy, so.
Michael, that's smaller. Michael, I'm sorry.
Good? So if I had this composition, F composed of G, and I put in a 4 for X, at the end, what do I get? Right? So this is my final answer for F composed of G, right? So I'm going to use this same one. That's this guy. And say F composed of G, but negative 4. So it'd be 2 times 4 squared minus 4 times 4 minus 7. Right? There's equal sign there. Was that 32? Minus 60? It asks you to do it. It's the last operation. So at least you've already done this. So all we're doing is putting a 4 in. Yeah. I don't think I'll ever, well, ever. That's tough. 9? What's 9?
What you get it.
Is that what we get?
4, I'm pretty sure anyway.
Yeah, because that's 23,
Yeah.
which equals 9. I wasn't done. My brain wasn't working. Cool? Yay. That's the difficult piece. All right. Okay, here's your task. You ready for a task?
Yes, sir.
I'm gonna, now that we've gone through this whole thing and we know what we're supposed to do, could you, yay, oh, that's a good one. Do number 3. Let me give you a, wow, number 3 should be real fast. 5 cubed is 125, by the way. All right, just keep that in your head. Do number 3. Give me both compositions, and then that first composition, input a 4. Go. You have 2 minutes.
What is
Say it again. It means this is being composed of this, right? It means I'm putting the G function in everywhere I see an X in the F function.
That one was pretty good.
Were you here for the last minute or more? Okay, so,
Just thinking about the same thing.
so if we have our 2 functions, right? So we have f of x is on the X cube.
That was Daniel Drexel Bass.
Is 5x.
This is some pretty
And so if I'm going to compose this f function with g, then it would be 5x to the third.
And
So for this one, it's just 5x.
And how do
Right? And so 5 cubed is 125. That's it. And we're done.
That's
Right? And so now we're going to do it the other way.
So then for 5, next you plug in X.
And so now we have 5 x cubed. Well, that's just 5x cubed.
And then you're done.
And then it says
Then you plug in
use
four.
this guy and plug in a 4. Well, I don't know what 125 times 64 is. Can you give me
Let me simplify this.
help with the calculator?
Alright.
Yeah, because 4 cubed is 64. 8 grand?
I don't think that's.
John. Yeah. Oh, yeah. That's easy enough.
I thought you said you knew that.
Thank you.
Sir,
I was wrong.
can you check if I'm right, sir?
He is fine.
Did you get 8,000?
Number 3, I got 5x to the power 4. For 2 of these, right?
Why 4?
Because when you add the.
We're not multiplying. We're putting in, look, hey. Come on.
Sir,
You told me you knew. You lied to me.
shouldn't the fog and waft be the same for this one?
No.
Operations.
No.
I'm confused, right?
So I have what? X cubed?
Oh, yeah.
So everywhere I see an X, I put a 5X. Then I cube it. What do I get? 125
Oh.
X cubed. Other way around,
Why'd you erase it?
5, put it in that X cubed. That's just 5X cubed.
Oh.
Okay? Wherever you see an X in the original function,
Then you just plug in the 4 for 125.
and now we're going to put in the 4 here, that's where we got our 8 grand. Right? We knew this was
We did that.
Yeah, we missed it too.
so I'm going to do 125. Oh man, I should have known this, dude.
That's 500.
It's $1.25, 64 times. Oh, I'm so dumb. Oh,
Sir, that's 600, right? Wait, no, 500. My bad.
you put in a 4, right?
Forgot
4
about
cubed
the
is
square.
64. 4 cubed is 64. 4 cubed is 64. So it's 125 times 64, which is 8,000. Thank you, Mr. Barry, for using the calculator because Silva couldn't do that in his head.
Oh, it's much more down on the screen. I got you.
Okay, okay.
Better, right? Better. Better butter?
See, so it's simple.
I don't wanna-
Annoying, right? It's just busy work is what it is. But we need to know, like, what if,
Sir, that's
like,
not
do,
8. Oh, wait.
so we're
8 is 8. I'm stupid.
like, I can't give you like a real world example of doing something like this, but I would imagine this is what computers are for, right? This is what programs are for. In sales, in business, there will be two functions combined at a specific point in time. And we'll want to know what a specific output is at that time. Like production, whether we need more product, who's buying what, when. There will be times when different demographics are working at the same time and you need to produce more. So that's where something like that might come in handy. Instead of looking at two functions, doing all the math, and then combining, this is just a simple thing that most likely a computer program will do for you. But understanding the idea that sometimes we have to compose. Okay, pull it at S. What are we?
10, 12.
It's
Like 15 minutes. 20 minutes.
So we have plenty of time. Let's see if there's a more difficult one. Oh, here we go. We hate these, right?
Yeah.
It's got a fraction, sir. I'll never be able to do it. Right? So try them both. Now. Oh, we gotta square it. Oh, I can't square 1/x. Oh, I don't know how.
I don't know.
Stop.
How to do that.
Yeah, you do. You square the numerator and you square the denominator. Come on, man.
Just when
Oh, you're just messing with me? Sorry. I thought you were being serious. I was gonna cry.
I did sleep a lot in math class last year, but I didn't sleep that.
No. She wouldn't let you.
you.
Yep. Hi. Do it. No do. No 5 points.
I try my best.
I did my best, but I guess my best wasn't good.
What?
You're just down to try.
Yeah, that's number 2.
Numero dos.
I think it's
Why'd you erase it? You're supposed to use it as a guide.
That's what I said.
I don't know.
He's an idiot.
Oh, he's not an idiot. Use your environmental print.
I got it in my head.
I
Remember how you do it. It's survival. Other kind of good well.
So.
I'm not writing it all out because I'm lazy today. I'm sorry?
Excuse me.
Dude!
I apologize. I'm better than that.
I understand. I just don't understand.
Wait, so what happens to the square?
Yeah.
What happens to the square? Can you just-
Oh, sorry. Sorry! Stop yelling at me.
Oh, no,
Yeah,
sorry.
Sorry. That was weird. Okay, good. Here they are. Here they are.
Oh, yeah, okay.
Yes.
Now you don't have to bustle.
I forgot the name.
I think I got it right.
This is such a weird. I can't believe they let me teach you guys. How did that happen,
That's
sir?
an interesting graph.
That's probably the easiest one we've had.
Wait, number 2?
Yeah.
So is 13.
We didn't have to do any work. What?
Is 13/16 equal to 0.8125?
I would imagine it sounds reasonable.
Okay.
Why can't you leave it as a fraction? Are you afraid of fractions?
Because Desmos doesn't give it to me as a
Then
fraction,
your physics work will be atrocious.
I'm not afraid of fractions. I'm actually
Oh.
better at doing the math.
Actually, I like fractions here, and I lied to you.
Probably at some kind of math, but not math in general.
If Dornberg like actually applied himself for
Yeah, he'd be dangerous, wouldn't he?
Yeah, but like, if Wu applied himself,
Yes.
he'd still be better than the E applied himself.
Hang on. I gotta hear that.
For a fall break.
I gotta hear that.
For a fall break. Don't you square the fraction first?
I do.
Why?
What is 1 divided by x squared?
What else? Stays the same.
Yeah.
Let's see.
You square both, right? You square this and you square this.
Oh, okay.
So it's 1 squared? What's x squared?
Let's see.
Right? Then we multiply by 3.
You don't understand.
Yeah, but it cuts your last
No, no. My grandma, now calling and she's like 87.
Good? Good?
I think so.
She's a- she had these-
I think.
All right, we made it. We survived.
Still fighting.
Hardly.
I wanted to get to the next section, but I don't think we'll be able to do it.
Which is okay.
We'll do it mañana,
As well as I got my drink.
tomorrow. Domani.
Bro, did you know that? Did you know that?
Yeah, I knew that.